Now they also give you some in the textbook. They give you some applications of using logarithms. I put a few here because there are some web work problems that kind of have you work with it, but they do give you a lot of the background information as well. But I figured to go over a couple problems involving that just to kind of make you somewhat familiar with it. But a lot of you have heard about the Richter scale for earthquakes. They'll say that the earthquake had a 3.2 magnitude or whatever it might be. I'm sure you've heard of it before. Well, what does that mean? Well, basically that number comes from me doing a logarithm of a ratio between the actual what they call seismic activities or the size of the seismic waves, which I can measure, compared to the zero earthquake. The zero earthquake, since there always is seismic activity, there always will be some sort of seismic waves being emitted by the Earth's movement. Because we have tectonic plates, they float on each other and all that stuff. But that does not cause buildings to break or us to be like shaken or anything like that. I mean, there's little earthquakes happening underneath us all over the world. There is actually a wavelength and a size for that and a constant for that. For this type of problem, you really don't need to do it because we're comparing. We're making a comparison proportion wise. So when we look at example 13, what would the Richter scale reading of an earthquake that was 1,000 times more intense than an earthquake that had a Richter magnitude of 5.8? So we have to kind of break it down and see how we go about doing this. So I'm going to take that 5.8 reading and I'm going to say, well, that's going to be my first earthquake, S1 over S0. So the log of S1 over S0 equals 5.8, which means that S1 over S0 is 10 to the 5.8 power, which means S1 is 10 to the 5.8 power times S sub 0. The second earthquake, the one I'm looking to find the magnitude, the Richter scale reading of, I'm going to call S2. That's 1,000 times more intense than S1. And I think that 1,000 is the same thing as 10 to the third power. So 10 to the third power times 10 to the 5.8 power times S sub 0 becomes 10 to the 8.8 power S sub 0. And that's what the second earthquake's intensity would be. Of course, I'm going to do a ratio of S2 over S0 because I want to, that ratio of comparing it to the original zero earthquake is what I need. And if I do a logarithm of that, that gives me 8.8, which is what the Richter scale reading is. So basically, you know, uh, adding 3 to the Richter scale reading is going to make that earthquake 1,000 times more intense, which means 1,000 times more damaging.